In this video, we're going to look at how we can balance chemical equations. So in this first example here, we see that we have the elements A and B listed. So what I tend to do is I kind of draw a dividing line here between my reactants and my products, and then I list how many of each element I have on each side to start. And we see here that we have one A and two B on our reactant side. Then we have two A's and one B on our product side. So we need to try to figure out what coefficients would be able to balance this reaction. So if I come over here and I put a 2 in this spot, that would change this to be 2A. So now my A's match up. So I can put a check mark there. And now I have 2b on this side, but only 1 on this side. So if I put a coefficient of 2 there, that would change this to be 2. And now I have a balanced chemical reaction. So I'm going to do the same thing down below here. I have my hydrogen and oxygen and like so over here. So I have 2 and 1, and then I have 2 and 2 on the reactant side. So I need to make that oxygen into a 2. So the only thing I can do is add a 2 coefficient, but that also changes my hydrogen to be 4 now. So I have the right amount of oxygen, so I don't want to change that over here. So I'm going to leave that as a 1. And then my H2, I'm going to change that to be a 2. So now I'll have 4 hydrogen atoms, and that will be balanced. So now I have 2H2 plus 1O2 gives me 2H2O. And let's continue to do this with the next few examples. So I have silicon, I have chlorine, hydrogen, and oxygen here. Let's write them over here. All right, so we have 1, 4, 2, and 1. And I'm getting these numbers just from those molecular formulas up above. So the subscripts, that's how I got these numbers here that we start with. So I wouldn't change anything but the silicon compounds just yet because those numbers are balanced. But then when I get to the chlorine, I see that I need 4 of those. So I'm going to go ahead and put a 4 out front here. That will change this to be a 4 and my hydrogens to be a 4 on this side. And then I kind of go back on this side and I see, all right, well, my hydrogens are only 2 and they need to be 4. So let's add a 2 here. So that will change this to a 4. And that also changed my oxygens to a 2. So now my oxygens are balanced, my hydrogens, my chlorines, and I didn't touch the silicon. And now there's 1 and 1 on each side. So everything is balanced. So I see SiCl4 plus 2H2O will yield SiO2 and 4HCl. So we can do this with our last two examples here, or three examples rather. So we have D, E, and F shown here. Try to make a little bit more space. So with example D, I would do the same thing as previous, kind of draw a dividing line here. I have H. I'm going to leave my polyatomic ions together. So I have PO4 and CN. I'm going to keep them together because they are also together on the product side. So when that's the case, it'll save you some time when you balance. So let's see here, we have three hydrogens to start, 1 phosphate, 1 sodium, 1 cyanide. Over here, 1 H, 1 PO4, 3 sodium, and 1 of the CN. So let's see what needs to change. Well, I need 3 hydrogens, so I'll just add a 3 coefficient there. That changes that and that. And then if I put a 3 over here to balance my cyano group, I can see that everything just kind of magically falls into place. I have the right amount of hydrogens. The phosphate is 1 and 1. Now my cyano, oh, and my sodium has changed to 3. So everything is balanced. So I have a 1, which I don't need to write, 3 to 3 to 1 ratio in this balanced reaction. Now, in this next example, we're going to learn a technique that is helpful when we see combustions of hydrocarbons. If we follow a certain order of balancing, and by that I mean we do carbon first, then hydrogen, then oxygen last on each side. And if we look at our products, they're always going to be carbon dioxide and water. And we always have one carbon dioxide, two hydrogens, and three oxygens to start on our product side. So that's how you can remember what order it's recommended to balance. Um, Over here, we start with two carbons, four hydrogens, and two oxygens. So I can, if my carbons were equal, I wouldn't put a coefficient in front of anywhere, but since they're not, I'm going to add a 2 here. That will change that. And then that updates my oxygens to be 5. So now my carbons are equal, but my hydrogens are not, so I need 2 in front to give me that 4 coefficient now. So now they're balanced. So I have carbons looking good, hydrogens looking good, and I've also added another oxygen. So now this is a 6. So we always do oxygen last because it's by itself here. And if I put a 3 coefficient out in front, that will give me 6 oxygen. So now I have a 1 to 3 to 2 to 2 ratio of my reactants to products in this balanced reaction. Noting again that with combustion reactions, so anytime you see CH or CH and O in presence of oxygen, you're always going to get these products here, CO2 and H2O. All right, so our last two here, we'll draw our dividing line again. We have iron and oxygen. I have 1 and 2. Oxygen and iron on this side. I have 2 and 3. All right, so we need to balance both. So I need 2 iron. So let's go ahead and change that to 2. But then let's see, I need 3 oxygen. So I need to change the coefficient over here to match. So I could multiply initially by 3 halves, knowing that that would give me 3 oxygens that I need. But since I can't keep a non-whole numbered integer here, I can't use a fraction, I'm going to multiply all of my coefficients that I have so far by 2, and I'm going to see that I need 4 Fe and then 3 O2, and we're going to end with 2 Fe2O3. So again, because I needed an odd number of oxygens and they are diatomic, I can put in that fraction temporarily, but then multiply everything by 2. And now I see that this is my balanced reaction above. 4 iron, 3 O2 can give me 2 Fe2O3. All right, this last equation here. Oh, actually, we have 2 more, so we'll move a little quicker now. Right, we have aluminum, we have hydrogen, we have chlorine on each side. And let's put our initial amounts, 1, 1, and 1. Over here, I have 1, 2, and 3. All right, so now we want to balance this. Where can we begin? Well, I wouldn't start with the aluminum, but and I wouldn't start with the hydrogen because that's all by itself. So let's look at our aluminum chloride here. I need 3 chlorines. Let's update that over here. So now I have 3 and 3. Now, notice my hydrogens. I have 2 on this side, but I need 3. So I wouldn't adjust that quite yet. Or rather, what I can do is do that half fraction trick here. So I need an odd number of an even number molecule here. So then I just go back. Oh, I go back and I'm going to multiply everything by 2 now. So my balanced final coefficients would look like this. I'm going to have 2Al plus 6HCl because I've doubled everything. Gives me 2 aluminum chloride, trichloride, and then we have plus 3H2 after we multiply 3 halves by 2. Oh, where do we go here? So 3H2. All right, and our last balanced equation here, this is another combustion reaction. So we're going to follow the 1, 2, 3 steps when we balance. So we're going to do CHO in that order. So I have 1 carbon, 2 hydrogens, 3 oxygens. Over here, I have 2, 6, and 2. All right, so I know I need a 2 here. That also changes my number of oxygen, so now I have 5. Now I need to get to my water to be balanced here, so I'm going to put or my hydrogen, so I'll put a 3 out front. That will give me 6. Oop. So that'll give me 6, and then 3 oxygens plus 4 more. Now I'm at 7. So now temporarily, I know I need 7 halves. So then I multiply every coefficient by 2. So I'm going to see my final equation 2C2H6 plus 7O2, right? That 2 cancels out in the denominator. And then I have 4 CO2 on this side, and 2 times 3 gives me 6 H2O. So follow that pattern every time you balance a combustion reaction, because it is harder to go back and change the other coefficients because multiple elements change at once.